The idea behind solar radiation management, or solar geoengineering, is to reflect a small percentage of sunlight back into space to cool the planet. Here are some of the ways that sunlight can be reflected back into space. Marine cloud brightening. It would work by making some clouds brighter, allowing them to reflect more sunlight.
The idea is that it might be possible to either extend the area covered by these clouds or make them a little bit thicker, preferably out over the sea where nobody's going to object.
The most commonly proposed method involves spraying seawater into the lower atmosphere, which in theory would make clouds whiter. Initial computer modeling has indicated that if the CO2 concentrations in the atmosphere were doubled, brightening stratus clouds off the west coasts of North and South America and Africa could cool the Earth sufficiently to offset the temperature rise.
The main worry over the cloud brightening methods is that they would cause quite a high level of cooling in a fairly restricted area. And it could actually affect the natural upwelling in the oceans that maintains some of the major fisheries in the world, off California and South America and South Africa.
Another potential method that can be applied on the planetary scale consists of mimicking the natural cooling effect of volcanic eruptions. By putting reflective tiny particles, aerosols, in the upper atmosphere so they can circulate on the stratospheric winds, we could theoretically block out a small proportion of incoming sunlight.
Adding aerosols to the upper atmosphere is considered relatively cheap and easy to deploy if the technology proves effective and safe.
Well, good morning. I've been asked to speak to three questions relating to solar radiation management techniques. And the questions are, under what conditions can you imagine proceeding with field testing and eventual deployment of SRM? What are the most challenging ethical issues that SRM presents? And what steps should be immediately taken to address these challenges? Putting it practically, with SRM technologies, you're injecting particles into the atmosphere. If you're talking about cloud whitening, you're injecting saltwater particles or potentially other particles into the troposphere, which is the clouds, in order to see what impact they have on brightening clouds and on, therefore, reflecting sunlight away from the planet. Alternatively, with stratospheric aerosols, you're injecting particles up above the cloud banks into the stratosphere, where they form basically a very fine mist, small reflective particles that scatter light and reflect some of it back into space to cool the planet down. With stratospheric aerosols, you're injecting particles up above the cloud banks into the stratosphere, where they form basically a very fine mist, small reflective particles that scatter light and reflect some of it back into space to cool the planet down.
I can't imagine stratospheric aerosols ever being deployed, although it's an idea that people have suggested would be used if there's a planetary emergency. I think that research that will be going on will bring up so many issues, some of which cannot ever be addressed, that it would be actually impossible to implement it in the real world. And I've written a paper that was published in Science earlier this year that showed that you can't test it unless you basically do full-scale deployment for two reasons. One of the tests is, can you create a cloud in the stratosphere of tiny particles that will last and scatter sunlight? So you can fly a plane up there and you can spray some sulfur out, but it would be into a pristine stratosphere, and how the system would react to that would be quite different than if there was already a cloud there, which you would do under deployment. So you'd have to test that basically by deploying it. The other reason you can't test it is you'd like to see what's the climate response to this permanent cloud. And because climate is so variable, you really would have to do it a lot of material for a long period of time so you could factor out the variability of the climate system. For example, this year, 2010, there was a very strong monsoon in India with terrible flooding. Last year, there was a very weak monsoon with drought. This natural variability occurs anyway, and so what happens if you start testing it and you get a strange monsoon? How can you attribute that to the testing? You can't. You have to go for decades, including different El Nino cycles, and calculate an average compared to the average without that. So basically you have to deploy it in order to test it, and I just can't see the world standing for that. I mean, you really would have to notify everybody that might be affected, informed consent, but of the entire planet. And you'd have to do an environmental impact statement. And I can't imagine everybody in the world agreeing to these changes. So I just can't imagine it ever happening.
Like field testing of SRM, because generally there's not much institutional review at universities for things that aren't directly affecting humans, sort of doing testing on humans. So if you're not doing a test on humans, then you don't have to have human subjects approval. But of course, if you put a lot of sulfur up into the atmosphere, that's going to come down somewhere, and it could affect humans, or maybe something we'd want to have some kind of institutional review on at least. And I guess I'd also want to make sure that these things are safe for people and the natural world before we go deploying any kind of SRM, especially given that some of the chemicals that people are talking about releasing into the atmosphere are dangerous both for people and the environment. And then what about our control over nature? Is it the right kind of thing for us to be doing to interfere with natural processes in this way? Or are there better alternatives? Could we instead reduce emissions of deadly gases and greenhouse gases, and also control climate change in other ways by being more efficient and using greener technology?